So just wait till Valentine's.
I don't got money to spend. Tomorrow I get my paycheck though.
All right, today we're starting trig identities. One thing you have to be ready for is you got to be willing to work, try something until you get it right. If you just try it once and don't do it, it's not going to work out. I'll show you as much as I can, but if you don't do it on your own, it's not going to work out. Anything I give you for notes today, whenever we have the quiz, which could be next Friday, you won't have any notes. No formulas, no notes, nothing like that.
You say next time.
Yeah, Friday.
No Friday.
Oh, no, well,
No
maybe,
swears.
well, we'll see how the week goes. Maybe Thursday or we'll carry it to next week.
Monday. Tuesday.
Yeah, we're gonna have 3 days to school next week though.
No, I
It's wild.
Tuesday. Next.
I don't know. If you don't try, it's not going to work out.
Okay.
If you keep asking someone, that's great to get you going, but sooner or later you got to do it on your own. There's only a few different things they can do, but they make it look like there's a lot of difference the way they write the problems. You have 6 trig functions. The way the identities work, most of the time, not every single time, most of the time, out of the 6 trig functions, you want to try to write things in terms of sine or cosine, and I'll show you what I mean by that. You also cannot avoid fractions. Adding and subtracting fractions are a huge part of this. Huge part. So don't try to avoid them, just enjoy them. When you're adding or subtracting fractions, if you find the least common denominator, that can take 2 fractions or more and turn it into 1 fraction. That's what we need to do. So to add or subtract fractions, you got to find the least common denominator. Then 2 or more can become 1. Just basic math. Please write this out. It's been a while since you've written this out and done it like this. To add fractions, you have to find the least common denominator so you have the same type of items. Okay? Can everyone see the LCD here is 10?
Yeah.
All right. So you make a note, LCD is 10. Which means this fraction's already being divided by 10, so it's fine. This one needs to change. Whatever you do to this fraction to make it 10 on the denominator, you also do to the top part to make it whatever it becomes. So if I multiply by 2, because 5 times 2 is 10, I also got to multiply the 2 by 2 to make it 4. And just a basic thing, sometimes you see things and you're not sure. So if I were to take a calculator, just look, 2 over 5. If I make the 5 a 10 and the top a 4, it's the same value. So you're not changing the value when you multiply, as long as whatever you do to the top part of the fraction, you do to the bottom part. So this will be 2 times 2 over 5 times 2 plus 3 times 10. Well, now you have the LCD, so you'll have 4 plus 3 all over 10. So you're taking 2 fractions, you found the LCD, those 2 fractions can become 1 fraction, and then now it's very easy to solve. Those basic steps will happen over and over again in this section. Okay, so we need to take, most of the time we'll have 2, not very often we'll have 3. We'll have 2 fractions, we'll turn them into 1. Okay, as we know, there's 6 trig functions. please list them. Okay, this will be the first part of what I'm talking about, to write things in terms of sine or cosine. This will be the first part of that. Okay? So you have sine, cosine, and tangent. The reciprocal functions, cosecant, secant, and cotangent. Well, if I say write things in terms of sine or cosine, this is what I mean. If I see cosecant, I can also write it as 1 over sine. So I wrote cosecant in terms of sine, or using sine. That would be a step that you would make quite often. Secant, you just wrote in terms of cosine. Tangent, again, you wrote in terms of sine and cosine. Move down. Cotangent, so when people say write them in terms of sine or cosine, that's what they're talking about. So you have the same value, just wrote it in a different term, using a different term. Pretty basic? There's also this notation. That's sine squared of theta. What that means is you'll take whatever sine of theta is and you multiply it by sine of theta. That's it. Cosine squared of theta. Tangent squared of theta. Pretty basic. If you have cosecant squared of theta, secant squared of theta, or cotangent squared of theta, or even tangent squared of theta, if you're going to write those in terms of sine or cosine, you would square the sine also. These are the little notes I'm talking about. When it's time for a quiz, you won't have any of these notes. These are things we just have to learn, and we'll learn it by working through the problems. So even if the original functions are squared, like the main two functions are sine and cosine, that's what we're used to, that's what we use on the unit circle. Then we start working with tangent, then the other three reciprocal functions. So besides sine and cosine, you have the other four. They can, even if they're squared, they can still be written in terms of sine or cosine. That's what it would look like. So as you start one of these problems and you're trying to get to the next step, if you see cosecant squared and you don't see something really obvious to do, you'll write that as 1 over sine squared. That's how you'll start the problem, which creates fractions, and maybe you get to add or subtract fractions, which is nothing but joy. Good? So those are some basic facts. Another thing is Pythagorean identities. There's 3 of them. If you're good at learning and memorizing, once you see the 3 of them, you'll memorize them, you'll learn them, and you'll use them. I'm going to show you a way, if you forget the second 2, they're really easy to find. That's what I use a lot. So Pythagorean identities. One of them sine squared of theta plus cosine squared of theta equals 1. And just before I go any further, don't write this down. I'm just going to show you. It'll get in your way if you write it down. I'm just going to show you. If I were thinking of the unit circle and say I went to 30 degrees on the unit circle. If I went to 30 degrees on the unit circle, that would be my exact value ordered pair. Well, what they're saying is if you square sine and you square cosine, the answer will be 1. Just as a basic example to show you what's happening. Okay, that's it. No big deal. We've used the unit circle enough, we can find any location and check that, and you'll see that it works every single time. Pretty clear? So one of the Pythagorean identities is there. I'm going to show you a way in case, what if I forget the second? Well, if I know the first, I can easily find the second. And if I know the first, I can easily find the third. So write those out, please. Once again, if you're good at memorizing, you'll see these, you'll know them, you'll use them, you'll be fine. You won't ever have to do what I'm going to do now. But if you ever do forget, especially in a quiz situation, this is an easy way to remind yourself of what the others are. What's that, bud? They're all the same, yeah, right now. So we ready? So let's say I remember the first, but I forget the other 2, or I get confused on the other 2. Here's how you find it. If you take and divide everything by sine squared of theta, and then you take and divide everything by cosine squared of theta. This helped in the past. A lot of people have a hard time memorizing things, so this is what I would use to help them find the other 2, because you're going to need them. So that would be a very basic step, right? Divide by sine squared of theta, divide by cosine squared of theta, each term. And then if you think of the notes we just had, This is 1. This is cotangent squared of theta. And this is cosecant squared of theta. So there's your second identity. Pretty easy. Plus a lot of fun. That was a lot of fun going. Make sense, everyone? So I want to find the third. There you have it. Sometimes you think of memorizing so many things and that bothers you and you worry about stuff. There's always a way to figure stuff out. So if you forget the 3, but you got to remember at least one of them, then you can easily find the other 2, because we're going to use it quite often. Any questions there? Okay. So there's our 3 Pythagorean identities. Now these you can add, subtract, move things around. Like if I were to say 1 minus cosine squared of theta, that would be sine squared of theta. Or different versions of that. Let's say 1 minus cosecant squared of theta will be negative cotangent squared of theta. Moving things around, adding, subtracting from one side of the equal sign to the other. This will happen quite often. Every once in a while, they'll try to trick us a little bit. They'll say, hey, you got secant squared of theta plus 1. Well, if you call that tangent squared of theta, that's not correct. So they have to be what they're supposed to be. If I were taking a quiz, the first thing I would do when I got my quiz, I would write those 3 things down. Because you're going to use them all the time. It's just easier if you're looking at them at the top of your page or on a separate sheet of paper. Make sense? All right. So, some basic style problems we'll start with. We'll use these facts to help us get through the stuff. We look at our first example. In this situation, you're adding fractions, you have 2 fractions. The goal here is like simplify we want to try to write this in terms of one trig function. So right now we have sine, we have cosine, we have addition, we have fractions. We want to try to write this as one single trig function. All right. I said most of the time we want to write things in terms of sine and cosine. Well, that's already done. It's in terms of sine and cosine. Now be careful here. Don't start thinking like this. If it's not squared, it's not a Pythagorean identity. Okay, it has to be squared to be Pythagorean identities. All right? So about all you can do here is add these fractions. I like to make clear my LCD in this problem is sine of theta times 1 plus cosine of theta. Everybody okay with that? So as soon as I know the LCD, I can turn two fractions will become one fraction. And that's going to be very helpful. So there's the LCD. So I'm going to write it right now, turn this into one fraction. Just like we did before, we had a 5 and a 10. The 10 was fine, but I had to multiply the 5 by 2. Sometimes when you have this situation, it's not a bad idea to put two terms in parentheses. It's helpful in a lot of cases. You don't have to. But if I look at this fraction and I look at the LCD, the 1 plus cosine is already in the denominator. What's not there is sine. Well, I've already multiplied this by sine to get this. I got to multiply the top piece also by sine. Here, the missing piece is 1 plus cosine, so I have plus cosine times the 1 plus cosine, so that the two fractions are now correct. The 2 became 1, and I can work from here. Once again, things are in terms of sine and cosine. So the one thing I can do that, to me, after practice, now this will take practice, you'll see, hey, this is obvious. Let me use distributive property right here. See where I end up. Leave the denominator alone. Can you see it's just step by step, fun stuff, like a puzzle. Enjoy yourself, make the most of it. So I just distributed the cosine through. Cosine times 1 is cosine, cosine times cosine, cosine squared. Just putting the sine squared and the cosine squared together. Our Pythagorean identity tells us that sine squared plus cosine squared is 1, so this entire value is 1. Remember, now we're trying to write this in one term. Once again, if you have two terms and one's in parentheses, if you put the other in parentheses, it makes it look a little better. You see those can cancel now, right? So you have 1 over sine. So that's now one term, but that can even become something different. So it's like all this stuff with a little bit of wonderful work became cosecant. So what this does, it helps you think, it helps you practice, it helps you work. Yes? Oh, because when you have a fraction, say you have 2 over 2a. Okay? Well, the 2's cancel, you just can't put nothing over a, right? So you always put a 1 on top. That's why, good question. Anything else? All right. I'm gonna show you another one.